Well, hello everybody, welcome to today's video where we're gonna look at the Cauchy-Schwarz inequality. So the inequality is as it follows. So the product of the sum of the square of two lists of the squares of two lists of numbers is greater than or equal to the square of the sum of the products of these two numbers. Okay, so this is an important inequality when you have to like approximate points, let's say. So it means that the equality case happens when your numbers are close, and close in this sense means being proportional. So plus equality if and only if there exists a lambda such that ai equals lambda times bi for every I in our set. Okay, great. So what's the idea of the proof of that? So it comes like from building a convenient function that will have ai's and bi's as parameters. Okay, so consider the function f of t, which equals a1 plus tb1 squared plus a2 plus tb2 squared, etc., plus an plus tbn squared. Okay, so then f of t is a quadratic function of t, and it's, of course, as a sum of squares, non-negative. Since it's non-negative, it means that its discriminant is less than or equal to 0, because we'll have at most one real root, right? Okay, so this is a very important observation. And now we just have to write these like to collect the terms, let's say. So this is a1 squared plus etc. plus an squared plus 2t times a1 b1 plus etc. plus an bn plus t squared times b1 squared plus etc. plus bn squared. So this is great, and now we know really well how to compute the discriminant, which is 4 times a1 b1 plus etc. plus an bn squared minus 4 times a1 squared plus an squared times b1 squared plus bn squared. So this is great, because this is exactly what we wanted from the Cauchy-Schwarz inequality. These 4's will cancel out. We can factor them out, and what we'll get is that delta is less than or equal to 0 if and only if. So we just do that. It's less than or equal to the product of the sum of the squares. And there we are. We have just completed our demonstration. Okay, so this is great. And once again, delta, and so like just as a final comment, let's say delta equals 0 if and only if there exists a single real root, and it must be 0. The sum of squares, the f of t, must be 0 at that point. And so how can it happen? All of these values right inside the parentheses must be 0, which means that there exists a lambda equal to minus t satisfying these. Okay, perfect. And then the ai's and bi's are proportional. So if you're trying to find like some inequality for which the equality case is like when you have proportional lists, this is a good try. Thank you, and see you in the next video.